I am Surya Prakash, Associate Professor in Mechanical Engineering. Today my topic is Applied Mechanics. The Module 1 content, Introduction to Applied Mechanics, Need for Engineering Mechanics, Classification of Engineering Mechanics, Characteristic of the Forces, Transferability of the Force and Parallelogram of Force. What is engineering mechanics? The engineering mechanics is the branch of the science deals with the effect of the forces acting on a body when the body is rest or in motion. Now here this is a body, this is a body. So now the body is in rest. The body is in rest position. The body is in rest position. Okay. So when you apply the some force, what is the effect of the body? We have to see in this applied mechanics. The other one is when the body is in motion. Okay, now we are applying some forces. What is the effect of the forces on the body? We will see in applied mechanics. Now the engineering mechanics is very essential for the engineering of the planning, designing and construction of various structures and mission. So the engineering mechanics are very essential in the planning. The engineer will be planning for the procurement of the material, missions. Okay, and also the designing. The engineer make a new component. Okay, that time we need the applied mechanics. And also the construction of various structures and the missions. Okay, the engineering mechanics is very important. Need for the engineering mechanics. So now in this need for the engineering mechanics, to design a car which runs at the 1200 kilometers per hour, the engine power and the forces acting on a car. So the rolling resistance and inertia to be estimated. When the car is moving 1200 kilometers per hour, so that we can estimate the rolling resistance and also inertia will be estimated. The second one is to determine the water pressure on the dam. Okay, the third one is to calculate the frictional forces between the wheels and track. Now this is the tire. Okay, now this is on the road. So now the frictional force can be estimated in this with the help of the applied mechanics. Next, the engineering mechanics plays a crucial role in construction of the roads, construction of the bridges, power transmission towers, robotics and electrical motors, etc. The construction of the roads means when the engineers are making the roads, that time we need the applied mechanics. When the construction of the bridges, the so many forces are acting on the bridge, that forces we can calculate. Next one is the transmission of the towers. Now here this is the towers. Okay, in this one how much force is acting on this towers we can estimate. So next one is the robots and electric motors. Next one, classification of mechanics. In that calculation of the mechanics, we can classify three different mechanics. One is the rigid bodies, deformable bodies and fluids. So now come to the rigid body. In the rigid body, do not change the relative position of the body under the action of the external force. Now you take example of one body. When you apply some force, okay, there is no change in this one. You can take this the structures. or otherwise you can take the example of the stone. When you apply some force, there is no change in the shape, so that is called the rigid body. When you apply some force externally, there is no change in the shape, that is called the rigid body. Next one is a deformable bodies. Okay, the deformation of the body under the action of the force. You take example of the paper box. In the paper box, when you apply some force, okay, when you apply some force, there must be some change. There must be some change. That is called the deformable body. The next one is fluids. The study of the behavior of the fluid is called the fluid mechanics. Now, in this rigid body, we can classify statics and dynamics. Statics and dynamics. It is a branch of the science deals with the study of the forces under the rest. Okay. Now, here the study of the force. Okay. Now, the body is in rest position. The body is in rest position. Okay. That time, okay, we will calculate the only the force. We will calculate the only the force when the body is in rest position. That is called this, okay, statics. Whereas the dynamics, okay, it deals with the forces, but the body is in motion. When the body is in motion, we will calculate the forces. That is called the dynamics. Again, in this dynamics, there are two types. One is kinematics, another one is the kinetics. Kinematics means the study of the body is in motion, which forces causes the motion not to be considered. Okay, so now when the body is in motion, the forces we are not considering. That is called the kinematics. Whereas the kinetic means the body is in motion, but the forces are not considered. The body is in motion, but the forces are not considered. That is called, okay, kinematics. Now, next one is the, okay, characteristics of the forces. Characteristics of the force. So now, first of all, what is meant by force? Okay, it is an action tends to change the state of rest or state of motion. It is trying to change the state of rest or state of motion is called the force. Suppose this one. Now it is in the state of rest. When I disturb the state of rest, that is called the force. When the body is rotating, I am disturbing. So that is also come under the force. Force means it is trying to change the state of rest or state of motion. Now, in this characteristics, the first one is the magnitude. Now, in this given diagram, now this is the force. Now, in this body, I am applying 10 newtons of the force. So now that force, the quantity of the force is called the magnitude. Now, how much applying on the 10 newtons? That 10 newtons is the magnitude. Okay, 10 newtons is the magnitude. What is by magnitude? The quantity of the force is called the magnitude. Next one is the direction. The line of action of along and towards which the force act in the direction. Now this one, how it is in this direction. Okay, wherever the force goes, that body is also same force, same route. That is the called the direction. That is the line of action of along and towards which the force act in the direction. Next one is the point of application. Now in this point of application, where we are applied the force. Now here I am applying the force at the center of the line. Now the 0 is the point of application. Sometimes I may apply here A. That is also point of the application. Next one is the nature of sense. The arrowhead marked according to the application of the force indicated, that is called the nature of the science, nature of the sense. Now here the force, wherever the arrow is the nature of the sense. So now in the characteristics of the forces, the first one is the magnitude, the second one is the direction, the third one is the point of application, the fourth one is the nature of sense. Next one, principle of transferability. Principle of transferability. Okay, now in this principle of the transferability, now this is a component. Now here I am applying the line of the action at A. The force is F. Again another force is B, the same one, but there is no change. Okay, so now if we move the force P at A to B, there is no change. That is called the principle of the transmission. Now here I am applying the force at A and also B, but there is no change. Suppose if I apply the force at A, now this is called the pull. Now if I apply the force at B, now it is called the push. The pull and push, it is called the principle of the transferability. Principle of transferability. Now here it is given that principle of the transferability. Principle of the transferability states that the force acting on the rigid body at different points along the force line of action will be produce the same effect on the body is called the principle of the transferability. That means, okay, suppose this is the component. If I apply the force here or here, but the line of the action is same. Suppose if I apply the force here, that is called the pull. Okay, now when you apply the force here, it is called the push. Now this is called the transferability, the principle of the transferability. Next one, parallelogram law of force. Parallelogram law of force. What is the use of the parallelogram law of the force? This parallelogram law of the force to determine the resultant of the two forces is called the parallelogram law of force. Okay, now here you take example of this one. Here I am applying one force P. Again here I am applying some force Q. So now the resultant is the R. So now this R is called the parallelogram law of the force. What is meant by parallelogram law of the force is, okay, to determine the resultant of the two force. One force is Q and another force is Q. The resultant is the, okay, parallelogram law of the force. So now in this definition we can able to see the parallelogram law of the force. If the two forces simultaneously acting on a particle, the two force, one is the P force, the another one is the Q force. It is simultaneously acting on the same magnitude and same direction. That is the same direction and same magnitude. Okay. Now this is the sides of the parallelogram. This is the sides of a parallelogram. It is the sides of the parallelogram. But the resultant may be represented the magnitude and the direction of the diagonal of the parallelogram which passes through the point of the intersection. Now this is the R. R is called the, okay, resultant. That formula is this one. This is called the parallelogram law of the force. Okay, the two forces are acting on P and Q, the same magnitude and the direction of the sides of the parallelogram. The resultant may be represented the magnitude and the direction of the diagonal parallel which passes through the their point of the intersection. Now this is called the law of parallelogram. Now the formula is here, R is equal to root of P square plus Q square plus 2PQ cos theta. 2PQ cos theta. Whereas this angle, in order to measure the angle tan alpha is equal to q sin theta by p plus q cos theta. Yes, thank you.